Hello friends, welcome back to this session. So in the last video we have started the exercise 1 from the topic complex numbers. So in this video we have solved near about 10 questions. So if you have not seen that video, please go through that video first and come back to this. So in the background, let me just revise in a minute that we started with the complex numbers and I have introduced the term I, which is known as the imaginary part and which is equals to root of minus 1. And we have seen the different powers of I to the power n. So there are 4 possible values. So I power 1 can be 1, it's minus 1, it can be minus I, or it can be plus I. So for different values of n we have these 4 values. Okay, so we have seen one small circle I to the power 1, I2, I3 and I4. Okay, so this is what we have I, this is minus 1, this is minus I and this is a plus 1. So these are the different values we have seen. Okay, and I have given you a small trick for this, how to remember. Just go through that previous video, you will get that trick here. Okay, so let's continue with the exercise 1.1. So in this video we will be covering 5 questions. So the first question is, it's 11th question. Okay, so what it says, find the value of 1 plus I square plus I to the power 4 plus I to the power 6 plus I to the power 8 plus dot 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 plus I to the power 20. Okay, we have to find the value of this. Okay, I told you that whenever you get any power of I, first we have to make it in terms of the square. Okay, let's see how we can solve this question. So let's write down all the terms given here. So 1 plus I square plus I to the power 4, I6, I8, I10, I12, I14, I16, I18 and last we have I20. So if you have seen the pattern here, 2, 4, 6, 8, then 10 and so on, then we have 20. Now first step is to what to do is convert all these n the power of I in terms of squares. Okay, what I mean, see here. So 1 plus I square can be written as I square plus I to the power 4 can be written as I square to the power 2. Then I6 can be written as I square into 3, okay, to the power 3. I4, I8 can be written as I square to the power 4. I10 can be written as I to the power 2 to the power 5. Okay, so this is I12 can be written as I square to the power 6. I14 can be written as I square to the power 7 plus we have I square to the power just 8, then I square to the power 9, then I square to the power, yes, it's a 10. Now what to do next? Just solve this. Let's see, we know that the I square value is what? It is minus 1. So keep that values here. So plus, it's I square is minus 1, so it's a minus 1. Then we have minus 1 square plus minus 1 cube plus minus 1 4 plus minus 1 5 plus minus 1 6 minus 1 7 plus minus 1 8 plus minus 1 9 plus minus 1 10. Now let's have the values here. 1 minus 1. See, remember that the negative ka even power is always positive and negative ka odd power is always negative. Okay, even power, so keep 1 positive, minus ka odd power take negative, even power positive 1, odd power negative 1. Okay, ये हो गया, even power positive 1, odd power negative 1. So positive 1, negative 1, positive, negative, then positive, then positive, then we have negative here and next we have positive. Okay, now let's see what can be cancelled out. So plus 1 minus 1 cancel, plus 1 minus 1, plus 1 minus 1, plus minus cancel. So what is remaining is only 1. So what is your answer to the question? So answer to this question is what? It's 1. Okay, it's very simple. we can have the another method to solve this. So I have already told you, if the number is divisible by 4 you will get plus 1, if the number is divisible by 3 you will get the I. Okay, so that part also I have told you in the last video. Please go through that video and check out. Next, check the question number 12. So it shows that show that I to the power 10, I to the power 100 and minus I to the power 1000. So it's 12. Show that 1 plus I10, 1 plus I to the power 10 plus I to the power 100 and minus I to the power 1000 is equals to 0. We have to show this. Okay, so what is the first thumb rule is first to convert the any power of I to the in terms of the squares. Okay, right, so it is 1 plus I10 can be written as I square to the power 5 plus I100 can be written as I square to the power 50 minus I1000 can be written as I square to the power 500. Okay, so it is 1 plus I square is what it is minus 1 to the power 5 plus minus 1 to the power 50 minus minus 1 to the power 500. Okay, you know that or negative ka odd power is negative, negative ka even power is positive. So minus odd power, so it's minus even power plus 1 minus even power is plus 1 but it's there minus as it is. So this minus as it is. So what is this? ये cancel हो गया, ये दोनों cancel हो गए, so it is equals to 0. Hence proved, hence we have showed that the given value, the given terms value is equals to 0. Okay, I hope it is clear everyone. So if you have any doubt you can ask me please. Okay, next question number 13 is 1 plus I14, I18 and I22, I14, I18 and I22 a real number? A real number. Real number. Is this given term is a real number? Justify your answer. Justify your answer. Oh, sorry. Justify your answer. So how you will justify this, whether the given question is real number or imaginary number? Okay, so if we simplify this and if we don't get any imaginary part, then it says, it concludes that it is a real number. Okay, so let's verify this. See here, we have any power of I. So what is the thumb rule says? First convert it into squares. Okay, so it is 1 plus I square to the power 7 plus I square to the power 9 plus I square to the power 22. Okay, so this is it. This 1 plus minus 1 to the power 7 plus minus 1 to the power 9 plus it's minus 1 to the power, oh, it should be 11. Okay, it is 11. Then what we have, it is 1 plus minus 1, minus ka odd power is minus 1 plus minus 1 ka odd power is again minus 1 plus minus 1 ka odd power is again minus 1. Okay, so what you are getting, this is equals to, it is 1 minus 1 minus 1 minus 1, these two cancel out, so this is equals to minus 2. Tell me, the minus 2 is odd number or real number or imaginary number? It's a real number. There is no iota there. Okay, so it's a real number. So how you will justify your answer? This is what our justification. And how you will write the conclusion? As answer does not include I term, this is a real number. Okay, this becomes a real number. Okay, this is what our conclusion is. Okay, very good. Now let's see the next one, question number 14. Question number 14 says, 14th one. So we have to evaluate I to the power 37 plus 1 by I to the power 67. Okay, I to the power 37 plus 1 by I to the power 67. So how you will evaluate this? So here again given I to the power any, that is 37. So what to do? First convert this into square terms. Okay, as the 37 is what, it is an odd number. So first write down, we can write that 37 is the I into I to the power 36 plus 1 divided by I into I to the power 66. Okay, so this can be written as, see here, I to the power into, see here, square. Now this becomes 18. Okay, I into I square to the power 18 36 plus 1 divided by I into I to square, so we have 33. Okay, so this is equals to, now the question becomes very simple. So so minus 1 to the power 18 plus we have 1 divided by I into minus 1 to the power 33. Okay, so this is equals to I into negative का even number, even power is what, positive 1 plus 1 by I, negative का odd power is what, it is minus 1, which is equals to, we have I, so this minus becomes plus I. Okay, so this minus goes here, so it becomes minus, so this I is as it is. And in the last video we have seen that 1 by I is equals to minus of I. Okay, so this we have proved already. So it is I, so it is minus of, so if I take this I in the numerator, it will change its sign. So this is equals to I plus I, this becomes 2I. Okay, so if you have not understood this, please watch my previous video, you will get it. So what is the answer to this question? Is it is equals to 2I, as simple as that. Okay, very good. Now let's see the next one, question number 15. It says that prove that. So what we have to prove? Prove that 1 plus I to the power 4 into 1 plus 1 by I to the power 4, it is equals to 16. We have to prove this. Okay, so our thumb rule says that whenever you have I, that is imaginary, in the denominator, take it in the numerator. Okay, so let's have, यहाँ पे तो सब by numerator में है, so let's keep that part as it is. Okay, we have 1 plus, okay, it is like this, 1 plus I to the power 4, 1 plus I to the power 4 into 1, see here we have denominator, so take it in the numerator, so it will change its sign, so it is to the power 4. This is I am taking as a LHS. So 1 plus I to the power 4 into 1 minus I to the power 4. Okay, now what you will do? So you can have, see here, 1 plus I to the power 4 can be written as 1 plus I square, 1 plus I square, 1 minus I can be written as 1 minus I square, and we have 1 minus I square. Okay, 1 minus I square. Again this 1 plus I square can be written as 1 plus I, 1 plus I. This part again can be written as 1 plus I and 1 plus I. This part can be written as 1 minus I and 1 minus I, and this part can be written as 1 minus I and 1 minus I. So it should be minus I. Okay, now see here, you know that the expansion of a minus b and a plus b, what is a minus b into a plus b is? This is nothing but a square minus b square. Okay, so can we have here 1 minus I and 1 plus I? So if I have the pairings like this, so this part 1 plus I goes with this 1 minus I. Okay, let's write this 1 plus I. Okay, let's have here the pairings only. So it is 1 plus I, 1 minus I, first pairing. The second pairing is like this, 1 plus I, 1 minus I. Third pairing is like this, 1 plus I, 1 minus I. And the fourth pairing is like this, 1 plus I and 1 minus I. Okay, and if I use this expansion, so what I will get? So for this 1 plus and 1 minus I will be getting 1 square minus I square, first part. Then for the second pairing again I will be getting 1 square minus I square. For the third pairing again I will be getting 1 square minus I square. and the fourth pairing again I will be getting 1 square minus I square. Okay, so I hope it is clear. So again this is equals to, see here, 1 square minus I square. So 1, what is the value of I square is minus 1, so it is minus minus plus 1. So it is 1 square minus I square, it is minus minus plus 1. Again we will get 1 plus 1, and again we will get 1 plus 1. So this is 2 into 2 into 2 into 2, this is nothing but 2 to the power 4, which is nothing but 16. So hence proved this is nothing but our RHS. I hope it is clear. Okay, so it's very very simple. Just remember the basic formulas. Okay, we have made use of this 1 a minus b and a plus b to the power a square minus b square. Okay, very good. So in this question we have seen that is one more concept which I have already explained in the previous video. That is, whenever you are taking the I in the numerator, it changes its sign. Not only in the numerator, you can take I from the numerator to the denominator also. Then also you have to change its sign. Okay, so any change, either you are from numerator to denominator or denominator to numerator, you have to be penalized with the minus sign. Okay, perfect. That's very good. Okay, now let's see the next one, question number 16. So it's very simple. So let's have the question number 16 here. So it's last question for this video. So question number 16. Find the value of I to the power 6 plus I to the power 7 plus I8 and plus I9, I8 plus I9 whole divided by I square plus I cube, I square plus I cube. Okay, so I will be solving this question as far as your board examination is concerned, and also will give you one small trick to how to solve this in just seconds. Okay, so our first task is to get these into the square terms. Okay, and if I see, if we observe this very carefully, we have I to the power 6 common in everywhere in the numerator. So if I take I to the power 6 common, what I will get is 1 plus, if I take 6 i's common, 1 I is remaining, so let's write that I here. From the 8 I am taking 6 outside, the 2 i's are remaining, and here the 3 i's are remaining, so whole divided by, now you can take I square common, so what is remaining is 1 plus I is remaining. Okay, so here 1 plus I square plus I cube, and you know the values of this. I to the power 6 upon I to the power 2 means what? It is I to the power 4. Okay, and here it is 1, and it is I is nothing but what? It is okay, let's keep this I as it is. Okay, plus, so this I square is nothing but it is minus 1, and I cube is nothing but again plus of I. So whole divided by, we are getting, okay, so I to the power 3 means what? It is minus 1, it should be negative of 1, minus 1. So here we have I cube, sorry, no I cube, here 1 plus I is as it is. Okay, so what you are getting in the numerator, it is I to the power 4 into, see, plus 1 minus 1 cancel, I minus I cancel, so it is 0 divided by anything. In the numerator you have 0, so 0 divided by anything, your answer will be 0. Okay, so as simple as that. Now let's see how we can solve this question using the trick. Okay, as I have told you, if the number is even, your options are what? It is a plus 1 or minus 1. So let me write this question as it is here. I to the power 6 plus I to the power 7 plus I8 plus I9 whole divided by I2 plus I3. Okay, now let's see here again. I to the power 6 means it's an even number, so whether it is divisible by 4, no, so not divisible means what? It's a minus of 4. I to the power 7, it's an odd number, is it divisible by 3? No, means what? It's a minus of I. 8 is an even number, so whether it is divisible by 4? Yes, so you will get as a plus 1. It's an odd power, divisible by 3? Yes, so what you will get? It's a plus of I whole divided by I square, so it is nothing but minus 1, and I cube is nothing but of minus of I. So here if you see minus 1 plus 1 minus I plus I cancel, so the answer is equals to 0. So you move in any ways, you will get the same answer. Okay, you can get this trick in the previous video. Okay, so I hope this is clear to all of you. Okay, and with this we will stop here and we will solve the remaining questions in the next video. Thank you.